my channel. So today we are going to start with the topic Earth's gravitational force. Okay, what do I mean by Earth's gravitational force? See, Earth attracts every body present on it. So the force exerted by the Earth on a body is known as the Earth's gravitational force or pull or weight of that body. Okay, so I can say Earth's gravitational force is nothing but the force exerted by the Earth on the body. On body. Fine. So it means what my weight becomes? My weight becomes is the gravitational force M into G. Okay. According to the Newton's second law, force is nothing but mass into acceleration. So here acceleration is the small g and that is due to gravity. So I say that small g is nothing but acceleration due to gravity. Fine. So gravity is what? Force exerted by the Earth on the body. Okay. Now next I am going to see we are going to derive acceleration due to gravity formula. Derivation for acceleration due to gravity. For small g I can write directly. Okay. See, weight is equals to what? The force exerted by the Earth, gravitational force. And in the previous video we have seen what is the gravitational force? Capital G, capital M, small m upon r square. Okay, this capital M is the Earth's mass, right? Small m is the mass of the body, r is the radius of the Earth. Now what did we see? Our W is nothing but m into G. Right, so can I substitute? So my m into g becomes equals to capital G, capital M, small m upon r square. So this mm gets cancelled. So acceleration due to gravity becomes capital G, capital N upon r square. All of these are constant. We'll substitute the value. Okay, and I'm considering the body to be on the surface of the Earth. So G is 6.67 into 10 raised to minus 11. Mass of the Earth is 6 into 10 raised to 24 kg and the radius is 6.4 into 10 raised to 6 the whole square. When I do the calculation, I get the value as 9.8. So acceleration due to gravity is 9.8 meter per second square. Okay, when the body is on the surface of Earth. Okay, now we are going to see, so I am considering, so let me take a mass, okay, of 50 kgs. So what the weight of this mass becomes? M into G, right? So 50 into 9.8 Newton or becomes the weight of that body on the Earth. Okay, fine. So next we'll see the change in G due to shape of the Earth, height and depth. Okay. Now we are going to see change in G. First factor I am considering is shape of the Earth. Fine. Change in G due to shape of Earth. Okay. Now what is the shape of the Earth? It is not a perfect spherical in shape. Okay. It is like this. Suppose I am considering it to be like this. Basically what I mean to say is it's little flat on at the poles. It's flat. Okay. Fine. And at the equator it is bulging. Bulging at equator. That means what? The radius of the equator, this is maximum. Okay. At the equatorial radius is maximum and the polar radius is little less. Fine. So now what we know, the force, this G what? Capital G, capital M upon R square. So at the equator, radius is maximum. At equator, it is maximum. That means what? G becomes minimum, and that value is 9.7 meter per second square. Okay, it's very slight difference, fine, due to this shape. And now at the poles, again G is equal to Gm upon R square. So at the pole it is minimum, right? That's why G is maximum at the poles, and that is 9.832 meter per second square. Okay, like this it keeps on changing due to the shape of the earth. Fine. Okay, this was a very small thing. Now next, and which is the most important one, is due to height. What happens when you go above the earth? Okay, that means suppose a satellite is going above the earth. So what is basically happening? How much is the force by the earth on that satellite? We need to see that. So change due to height, or change with respect to height. Okay. Now I'm taking my body. See, this is my earth. Okay, with the radius r. Okay, so I'm taking my body of mass m to be here, and this height is of, this is my body h. Fine. So I'm considering that. So my distance, so what my gravitational force, acceleration due to gravity becomes Gm upon, instead of r, now I'm going to take r plus h, the whole square. So this means what? As you are going above the earth, the gravitational force decreases. Okay, so acceleration due to gravity, decreases above the earth. Decreases. Okay, above the earth. Fine. Okay. So now next we are going to see change with respect to depth, and the most important thing, how it's going to change. Depth means what? I am keeping my body inside the earth. Okay. So now let me take, this is my earth. Okay. It's a uniform solid sphere, and this is my center. So the radius is r. Okay, now I'm considering my body to be somewhere here. So the below the depth is, I'm considering d. Sorry, d I'm considering my depth. Okay. So now what this? If I'm going to consider this to be another sphere, what is the radius of this sphere? The radius of this sphere is r minus d. Fine. Now see, gravitational acceleration due to gravity on the surface of the earth is what? At this point, G is equals to capital G, capital M upon R square. Here this M is mass of the earth. Okay? So now what is my mass? Mass density is equals to mass upon volume. Right? So I'm considering what is, so mass becomes equals to density into volume. For the earth, density I'm considering a uniform solid sphere. Uniform solid sphere means I take the mean density to be rho. Okay. So my density is rho. What is my volume? 4 by 3 pi r cube. So let me substitute this value in this equation. So my G becomes equals to capital G rho 4 by 3 pi r cube upon r square. So I get the value of G as 4 by 3 capital G rho pi r. Okay, this is my G. Put this as equation 1. Okay, I'm going to erase the rest of the thing. Now I'm going to consider the sphere at which surface this body is kept. Okay, so I'm considering the second sphere. Fine. So I am considering the acceleration due to gravity of that sphere to be GD. Means acceleration due to gravity, okay, at the depth D. Okay? So what it is? It is again gm dash upon. Now what is the radius of this sphere? R minus D, the whole square. Okay? Now what do I mean by m dash? That means the mass of this second sphere. Okay? See, m dash is equals to what? Again, density of the second sphere into volume of the second sphere. Now density I am going to take rho. Okay? Why? Because we have considered the earth to be uniform solid sphere. That means its mean density is rho. We are considering it. Okay? Now this volume is what? 4 by 3 pi. Now r minus d the whole cube. Why we are taking this? The volume of a sphere is always 4 by 3 r pi r cube. Okay? And here the radius is r minus d. Now let me substitute this into this equation. Okay, what do I get? Fine. So what do I get? GD is equals to G. Now this becomes rho 4 by 3 pi r minus d the whole cube upon r minus d the whole square. So only this is left, right? 4 by 3 pi r minus d. Okay, this is my G and D. Okay, now I am putting this as equation 2. Now divide GD by this G value. What would I get? Now this GD upon G is equals to, this is capital G rho 4 by 3 pi r minus d upon, this is capital G rho 4 by 3 pi r. So this everything gets cut and I get r minus d upon r. Fine. GD upon G. So if I consider depth, this depth to be equals to r, that means I am taking C. I am considering my body to be placed at what? R is equal, D is equals to R. Okay, that time what is going to happen? Put depth is equals to the radius of the earth. That time means body is at the center of the earth. Body at the center. Okay, what it becomes? GD upon G is equals to R minus R upon R. Okay, so 0 upon R becomes 0. That means my G and D becomes 0. That means the gravitational force at the center of the earth is 0. Okay, now see, when we go to look at this formula, G is equals to Gm upon R square. Okay, when we are going down inside the earth, radius is decreasing, right? The distance between the center of the earth and the body is decreasing. So basically gravitational force or the acceleration due to gravity should increase, but by this formula it shows that it decreases. According to this formula, it shows that the acceleration due to gravity decreases even when we are going inside the earth. Why? See, look at this earth. Okay, this is my earth. Fine. So when I am taking my body to be here, how much is the mass which is attracting this body towards itself? It's less, right? The mass which is trying to attract the body is now less. That's why the acceleration due to gravity decreases when you start going inside the earth. Okay, when you are on the surface of the earth, lot of mass, the earth is having such a great mass. with that force it attracts that body. But when you are going inside, the mass of the earth is decreasing, which is acting on the body. That's why the acceleration due to gravity decreases due to the mass which is up, which is trying to attract that body. Okay? Now next we'll see. Okay, all this is done. So we should always remember GD upon G is equals to R minus D upon R. Fine, this is a formula to remember. Fine. Now, see, when we look at this formula, what we can conclude. See, look at this formula. G is equals to upon R square. So basically the earth is attracting each body with a constant acceleration, right? But when I release two bodies, so according to this, everybody should reach earth at the same time, right? See what has happened. It was the scientist Galileo. What he did, he showed that when you drop two bodies, they both reach at the same time. Okay, so basically the earth is attracting each body with the same force, you can say, right? So why, if I'm taking a feather and the stone do not reach the earth when we drop, do not reach the earth together when I drop it, okay, they both should reach the earth together, right? So we are going to look at that, why they do not reach the earth. See, a heavier body always reaches the earth faster compared to the lighter body. Why? See, when a body is falling, see, this is my body. The three forces are acting on that body when it's falling. Earth's gravitational pull, which is acting downwards. Okay? Upthrust of the air, which is acting upward. Upthrust of air. And second is the resistance due to air. Resistance, I can say, with air. It also acts in the opposite direction. Okay? So when the stone is falling, the gravitational force is more, right? It's equivalent to its weight, correct? But the resistance, upthrust of the air and the resistance with air is less on that body. Why? Because of its weight. Okay? And when a feather is falling, suppose this is my feather, the upthrust is more on that feather. That's why the gravitational pull is little less due to upthrust. Always that air is trying to pull it up, and due to its light weight, the more upthrust is active. Upthrust by air is more on a feather. Okay, so that's why stone reaches the ground first and the feather reaches the ground later on. Okay, so suppose if I am considering two stones, okay, two stones, one is of 50 kgs and the another one is of 30 kg, and I drop it, they both would reach the earth together almost simultaneously. Why? Again, the upthrust is less compared to the gravitational force on both the bodies. It's due, see, upthrust always depends upon the shape of the body, the size of the body. Okay, so it is little less on the stones. That's why they both reach the ground faster and simultaneously. Fine. So we have to remember the acceleration due to gravity does not depend upon the mass of the object. Okay? So this all were the things we were supposed to discuss in this topic. And if you like my video, do give a thumbs up, subscribe to my channel, and do not forget to share it with your friends.